Can you hear me?
So hello everyone and welcome to the third day of Astro Sprint Discovery. And the next 2 days, that's today and tomorrow, we are going to cover some amount of tools, right, which are used by researchers, by
Git and
astronomers.
GitHub.
Yeah. So today we are going to do,
Sound.
yeah. So today we are covering Git and GitHub because, I mean, you are all aware that when you're doing data analysis, there's a lot of programming that is involved, and the way of sharing your programs with the community as well as with your collaborators is via Git and GitHub. And therefore, it's very important to understand it. You will also see that there are lots of papers for which, the authors actually put up their code in GitHub, and you can actually download the code and work out the paper using the material they've put. But for that, you need to know how to use these pages, how to update the codes, and how to share your codes with your collaborators, right? So that's what we're going to talk about today, Git and GitHub. And tomorrow, what we're doing, we're going to cover Overleaf as well as LaTeX, which would be, the publishing tools which we use, which use LaTeX, and we show you how to make your CV, how to write an article, how to do reports, how to make posters in LaTeX using Overleaf, right? So that will be tomorrow, 6 o'clock. But today, welcome Chetan. And Chetan is going to tell us about Git and GitHub. And I'm sure you. So over to you, Chetan.
Thank you, Dr. Priya. Hello, everyone. My name is Chetan, and I am a research intern at Academia Sinica Institute of Astronomy and Astrophysics, also called ASIAA in Taiwan. And I'm doing this remotely, so I'm currently in India. And I'll be talking about Git and GitHub today. So I'll also, at the end of this talk, Dr. Priya asked me to talk about myself as well. So I'll do that. So I'll briefly go over my journey and let you know what exactly I am doing and how I started doing what I am doing currently. So let's start with the Git and GitHub introduction. And we'll first start with the Git and then I'll move on to GitHub. And this introduction will be so that it will cover the basics and it will also cover how Git is working under the hood. But I won't go into too many details since that won't be necessary in your astronomy career.
Chetan, your voice is breaking a lot. Is it the same for others or?
Is it fine now, ma'am?
Yeah, now it's better. Now it's better. But others, it was breaking a lot at that point. Okay, very good. The others are saying it's fine.
All right. So,
the others say,
all right. So feel free to let me know if you have any questions in between, and you can use the chat, but I think it will be a bit difficult for me to monitor the chat. So if you want, you can unmute yourself and ask questions in between as well.
I'll monitor it, don't worry.
So I'll start with Git. So Git is a source control system or a version control system. And what we mean with a version control or a source control system is simply that whenever we are doing a project, let's say we have 10 codes and we have around 100 files in our in one folder, and we say that this is my project folder and I am doing some project. So I want that if I'm making this code throughout the duration of, let's say, 1 month, I want to make checkpoints in my code. So let's say that I build one functionality and I want to say that this is a save point. This is a point that at which I feel that this functionality is complete. Now I want to move on to other functionalities, but I want to make a backup of this particular functionality as well, or this particular time. So what I can do is make a whole copy of this folder and say that this is project version 1, project folder version 1, and then make the second copy, that is project version 2, in which I would be working now. So the version 1 now acts as a backup, while the version 2 is the live version for me now. And I can continue this so on and make backups of my whole folder or whole project folder. So I'll say version 1, version 2, version 3, and so on. And this is the most traditional way to do version controlling. And I think we all might have done something similar to this sometime in our project careers. But there are also other methods to do this, and one is using Drive, Google Drive. So if you have seen this, If you upload the same file twice, if you make a small change, so for example, I was making a change in this particular presentation itself, and I uploaded two versions, like one and the other, and and the drive overrode this file, the earlier file, with a version 2, so that I can also refer to version 1 if I want to at any point of time, that what all was there in version 1 and what all is there in version 2. So that is another way to do this, and that is done by Google Drive, Dropbox, and other cloud storages as well. But we want that we can structure this in a more sophisticated way, but a flexible manner for our code and our project, and that is what Git allows us. So why Git and why use it and why is it useful for us? So these are some points that I have written. So we can always revert back to our older versions of the code. So that means like we can always see what code I made at that point of time or this point of time and what is the change in between them. And then we also have a maintained history between these checkpoints. So we can say like I make a checkpoint every day or after every functionality that I complete, and I can see like how did I build those functionalities one by one. And these checkpoints, I would refer to them as commits. This is a terminology that we use in Git. That is a commit, which is nothing but a save point or a checkpoint for now. I'll go into more detail in the later slides, but for now you can think of it as a checkpoint of our code or our folder. Then the third main benefit for using Git and GitHub is basically we can collaborate with multiple people, and we can do this parallelly. So we have something called branches in Git. So that means we can work parallelly on the same code, and when we are comfortable with our versions of functionalities, we can merge those codes at any point of our time. And then there is this huge benefit of using Git, that is it uses less space than using the traditional method of making versions, because like when we are making versions, we are just copy pasting the whole folder, while in Git what it does is it just tracks the changes between different versions and not copy the whole versions. So it just tracks the delta between the versions, and then also it keeps track of all these changes for us, and it is very convenient for us to look back at any time. So let's talk about how Git works and what is happening under the hood. And for the sake of simplicity, again, I won't be going into much detail, but I will still be going into that amount of detail that is required in astronomy and often enough. And as the meme on the left says, one does not simply understand Git. That is really true. If we are going into too much detail of it, it will get confusing for us. But since we are not developing things in Git, we are using it as a tool in our astronomy projects, we can overlook those puny details and just work on this higher level of abstraction. And one disclaimer, a lot of slides in this whole presentation draws motivation from Dr. Jason Wong's slides and in Code Astro, that is another astronomy workshop that they hold every year, and it's a free workshop. You can also check this out at the link I have shared in the presentation itself. So let's start with the Git mechanics. And the first and the major part of Git is Git repository. And you can think of it as just a folder. So let's say that we have a folder that we want to put all our code and files into. And this folder we can call as a Git repository. The difference between a normal folder and this folder is that it has a .git subfolder. So what this .git does is it just tracks all the changes between the files that we want to track, and it maintains all the versions and does all the version controlling that we just talked about. So a repository is basically a collection of codes and other files in a folder, and we can just track all the changes that we want. And this is generally the first step in our whenever we are using Git. So for the first step, we take a folder, or if we already have some codes, we take a folder and initialize a repository. Or if we are just starting out with a new project, we just start with a git init. This is the command that we used in Git. And so for context, Git is used in the terminal. So everything I'm talking about would be used in the terminal. So for people who have Windows, there's a Git SCM terminal that is separate. For people who are having Macs, like Git is inbuilt, so you do not have to download or install anything. For people who are using Ubuntu or any form of Linux and Windows, we will have to install and download Git. And we will be doing like a quick hands-on session after we go through the mechanics, and you can download and install it then. There is a link, like I have put in a link in the slide, so I'll also copy paste that in the chat and later on. So the first part is like taking a folder and doing a git init that initializes that folder as a repository, and that creates a .git subfolder in it. So like whenever I do this, this is on the right, you can see I have just symbolized a .git subfolder. And after, so this is an example of what's happening, and I have just made a new folder that is called example tutorial. This is just a screenshot from my terminal, and I have put git in it. Then there are these lot of hints that it's giving. So this is just for the terminology and so on. You can ignore those hints, but this is to say that there is a initial branch that it works on. So that is a one main branch of our repository that we are working on. We'll go into detail of branches later, but consider it as one pipeline of our work. So that is in using the name master. If we want to change this terminology, which is actually recommended because of the because of the traditional naming that is being removed slowly. Master slave is replaced by main and main. So you can also change that, and you can connect that with the GitHub. So we'll be going into more detail about that later as well. But what this does is it creates a new empty Git repository, and you can see on the second last line it says that initialize empty Git repository in the folder that we have created this Git repository into, and you can see that there is a subfolder .git at the end. So this is just to make this repository. So let's say we have created this whole repository. What next? So whenever we are creating a project, we'll create some Python files or some any other language code, or some any file, that data file that we want, any attribute file that we want. So let us create a new file, and on the right you can see I have created a new file. So this is in this tutorial folder that I'm working in, and I have created a new example file that's called python example.py. And on again on the right, you can see that there is a small set of code that says welcome to AstroSprint, and it also prints like this is a Git and GitHub tutorial, and I have initialized 2 balls and so on, and printed those colors. So it will print like color of ball 1 is blue, color of ball 2 is red. So this is just an arbitrary set of code that I wrote. And you can also like write anything in Python or in C++, any language that's favorable to you, or any file itself. And we save this file in the folder. So on the left bottom side, you can see like there is this example tutorial, and I have this file in this folder. So after we have created a file in our project, what we want to do is check the status of Git. So once we are in the folder, once we are in the Git repository folder, we type in the command git status, and that tells us what is the current status of all the files in that git folder, whether it is tracked, whether it is untracked, what are the versions we are in, what are the commits that we have made. Commits are the checkpoints, if you remember I told you earlier. So how many checkpoints have we made, or what checkpoint are we on, and what branch are we working on. So these are some things that git status tells us. And let's also see like how this works. So here you can see another example where I am just in that folder, example folder, and I have written git status. So it says that I am on branch master, since I have not changed the name of this branch. So it's still saying master. It says that there are no commits yet. That means I have not made any checkpoints. Since this is really fresh, I've just made a folder and added a file. And then it says that there are untracked files in this, and it also gives me a hint of what to do with this untracked files. And it says that this is the untracked file, the python example.py. So what I want to do is also given in the hint. I want to stage these changes so that it can be tracked by Git. So that can be done using the command git add and then the file name. So I'll go ahead and do this. And this process is called staging. So it is used like for adding a file into the Git and then saying that please track this file, please track all the changes. and use this file in the git commit too. So in the checkpoint, I'll say that I have added this file. So once a file is added, every change in that file is tracked. And if you want to like include a huge number of files, so let's say that we already had a code and already had 100 codes in our folder and we wanted to add all of them, we can use git add star. Star means like everything in the folder would be added, but like as is mentioned in the end, a word of precaution: whenever you are using git add star, it will stage literally all the files. So make sure that you are not uploading any files that are not meant to be uploaded, like some data that might be proprietary or some data that might be like a file that is over 100 MBs. So that won't be like useful if you are connecting to GitHub, because it has a certain limit of file size for single files. And so make sure that you like add files very carefully. And if
Chetan, just a minute. There's a question. Where does the git init.py file go? Where
so
do you?
right, I'll just
Because
show.
many, I think, are sitting with their laptops and trying to do. So you make a folder, right? And then how do you? Could you open your terminal and maybe we could see?
Yes. So we will be going through this. Like I will be actually going through all this in a hands-on.
Okay, no problem. Then you can do. Go ahead. Go ahead then.
But to answer this question, it does go into so if you make a folder and do git in it, it won't be shown to you because it's a hidden folder. But if you type in your terminal cd.git, you can land into that folder and see like what is the folder structure. And we'll be going into this detail later on as well. So it just makes a subfolder in the folder that you are in, that you're making the repository of.
Okay, no problem.
And yeah, so I was like talking about git add star. So as I said, that there might be some files that you do not want to add into your git repository, and that can also be ignored by a new file that is called .git ignore. If you make this file, you can type in all the names of the files that you want to ignore. So whenever you do a git add star, these files won't be added to your git repository. That means that these files would not be tracked by git. So you can also generate this file automatically using GitHub, and I'll also go through this when we are doing the hands-on session. But to understand what git ignore does is it just adds in files that we do not want to track, that we do not want our git to track at all. And so for now, we will be doing what is on the right side. So we will be adding our example python.py file. So I'll just write git add example python.py, and let's see how that goes. So I have here added git add python example.py, and that's all. It does not give any output. So we can check what our status of the git repository is using the same command that we talked about, git status, and you can see it on the bottom now. So git status, it's still on the branch master. We have not made any change commits, so that means we do not have any checkpoints yet, but we have added a file that is python example.py, and that is now staged. So these are changes that are to be committed or that are to be added as a checkpoint. So whenever you are making a checkpoint, we have to add the files that we want to track in that commit or in that checkpoint. So it also says like it gives us useful hints, so you can also check these hints. So it says that if we mistakenly added a file in this staging or in this add, we can remove this using git rm, which is to remove these cached file name. And let's move on to the next part, that is git commit. So once we have added this file, we will do a git commit, that is to make a checkpoint. But how git makes a checkpoint is using a commit, that is to say that is a most fundamental or the atomic unit in our code, in our git system, basically in our git model. So what it is, you can think of it as an object which stores in. So let's go to the right first. So you can see that this is an example commit, and it is kind of an object which has an ID, that is some digits of numbers, alphanumeric numbers. It has a parent ID. that says like which commit is it next to. So if there was a commit before this commit, it will have a parent ID. Then it will have these changes that are to say the delta in our code, like what is the change in our code. So like it can say that I created a file abc.py which added from line 0, and this text would be all the code that I added in this file. Then it can also say that I modified this another file pqrs.py or something, any arbitrary file that we can add or delete. And it says that I added some line 12 and deleted some line 36. This is just arbitrary, but think of it just as an object which has all these set of properties, an ID, a parent ID, the changes that we made based on like the previous commit and the current commit. And then there is a message that the user gives. So the user can say like made XYZ changes in abc.py and pqrs.py, again, arbitrary changes that the user made. And this message can be anything that is useful to you for understanding what this commit did. And then there is this author. This is just some metadata that commit associates with it. So there is an author, the email who did this change, and the time at which this change was made. So like going back on the left, so it says that git commit is just an object which logs or saves all the changes as form of a checkpoint which has all these properties. And we can also revert back to previous git commits using this parent id thing. And we can like think of these as just like programmatical objects, or just normal objects which has some set of properties which have this id, parent id, changes, messages, and some metadata. So let's see how we can do this in our own folder. So if you remember, we made this folder example tutorial and we added this file example python.py. So a git commit holds all the changes compared to a previous git commit. But since we are just initializing our repository, that means like there is no parent to this commit, that this is the first commit. So when we do the command on the right, git commit a hyphen m and some message, it assigns an ID. This is the object on the right. So this has an ID. This has a parent ID, which is none because there was no commit before this. This is the first commit, and it tracks changes. So what are the changes over here? We created a file that is example python.py, and we added some text. So what is this text? This would be the whole code that is in our like a system. Like we added in this example python.py file, and this was added from the line 0. And then this is the message that we attached. So if you see the command on the top, it says git commit hyphen m. So this hyphen m is the option to choose a message for our commit, and it is mandatory. So we have to choose a message for our commits. And we say that this is an initial commit. I added file name. The file name was example python.py. And you can make this like easier for you to understand. So whatever makes sense to you. So this is like making our first commit. We made a checkpoint of our folder. We made a checkpoint of our repository, and we have one commit in that which added one file. All right. So if we see how this looks in the terminal, I just committed after we added this thing, we just committed the whole code. So I said git commit hyphen m initial commit and so on, the message. And you can see in the starting, it says master. That means we are on the branch master. It says that this is the root commit. That means it is the first commit. It does not have any parent ID. Then there is this ID E62DFEA, or this is just a random alphanumeric number. And then we have the message that we put in. So initial commit, added file example python.py. It then says what are the changes that we made. So we had one file that is changed, and we had 8 insertions. So these are just the lines of codes that we had. And this plus sign signifies that I added 8 lines of code in this one file. And then this created a mode. So we won't be going into more details about the mode, but it's just like it creates a mode or a particular ID for each file as well. So we added this file python example.py with 8 insertions in it. And that's all. That was a commit. And if we now check what our status is, So it removed what it was earlier. So if you remember, there was this git, when we did git status, it said that there was an untracked file. After we added it, it said that there is a file that we need to commit, and now there is nothing to commit. We are working on a tree that is clean. All right, so we are on the branch master. All right, so I see something on the chat. Are there questions? All right, for that. All right, so I'll move on to the next part, and this is a git commit tree. So what a git commit tree is basically a chain of commits. So we made our first commit, we have an object in our git file, but what if we want to make another change? So I just added a new ball in the code, in the Python code. So if you remember, the Python code was like ball one is equals to red, ball two is equals to blue. I just added a new file, a new ball, that is ball three is equals to green, any arbitrary set of change. And then I'm also printing that. So I made 2 lines change in my code, and I now want to commit this change because I think that this is a good point to have a checkpoint of my code and have a backup of whatever I did. All right, so what I'll do is, again, I'll get add that thing. So I'll get add the example python.py so that I can stage that I have to track these changes that I made. So first of all, I'll get add, and then I'll get commit. And then when I do this, what get commit does is it creates another object. And on the right, you can see like this object again has an ID, alphanumeric ID, that is completely random. And then it has a parent ID. And this parent ID is the same that we had earlier. So if you see here, we had this parent ID E62DFEA, and it had a parent ID none. But now we have this, I'm so sorry. Yeah. Now we have this new commit that is this F8 something, and it has a parent ID on the right. You can see like E62DFEA. And then it also tracks some changes. So it says that I added some text on line 6, and I added some text on line 10. And the text would be like, for line 6 I added ball 3 is equals to green, and for line 12, line 10, I added like print ball 3 is equals to, like, color of ball 3 is equals to like green, or so on. And then the message that I want to add. So again, in the command that I am passing on this message as well. So git commit -m, and then I am just writing a human readable comment. Sorry. So it says that I added a new ball in the example python.py. And when we do this, there is this tree, or right now it has just 2 nodes or 2 objects, but it's still a tree. And if you see the arrow over here, so arrow is pointing upwards. That means all the commits only have ID for its parent and not for its child. So that is to say, the earlier commit does not know where it is going to, but the current commit knows where it is coming from. So that is, it is like reverse linked, not a forward link. So you can always track back changes, but not track forward changes. And this is helpful while we are doing branches. And you'll see why this is helpful in the later slides. So and another thing on the left, if we go through the points once. So for the first point, we are saying like we have made it some change in our code. For the second point, we are saying that we are making a new commit to save these changes at deltas, and not entire. Again, this is just to look back. We are not making entire copies of the whole folder, or the whole Python file. We are just tracking the deltas or the changes. As you can see over here, this is just adding 2 lines of code when we are taking the backup, instead of like making whole version 1, version 2, and so on. And then again, this commit is connected to its parent using the parent ID. So let's see how this looks. So this is the set of code that I changed. On line 6, you can see like there is this ball 3 is equals to green. And I have also added in the last line print the color of the ball. And when I want to do this, so I first check. So this is just like whenever you want to do something with the git, it's good advice to like check for the status where we are at, so that we can get a sense of what we need to do. So I did a git status first, and it said that changes not staged for commit. So that means I have to add this file. And you can now see another hint that is present here. You can also discard these changes in the working directory. So let's say you made some change that messed up the code, and the code is not running now. So you want to recover your code to the last commit. So you can do git restore and that file name, which will take the last commits Python file and restore it to that. But we won't be using it. We just want to, we know that our code is working fine. We want to commit it. We will add our file to the staging area, that is like to say please track these changes for our commit. So we are saying git add python example.py, and we are then committing it. So git commit -m and then the message, and you can see like it says that there are 3 insertions and 1 deletion. I guess there were some extra lines, that's why it's saying a deletion, but in totality there were like 2 lines of code that were changed. And this can go on like together. So we can make more changes. We can add like this line of code in white. So someone say, I'm sorry, I guess someone is not on mute. That's fine now. So on the white text over here, you can see like I've just made another change in the code and I want to make another commit. So you can see on the right, like the commit trees goes on adding new objects or new commits to the tree. So if I were to make this change in my code, which says like ball2 is equals to input. So I'm just taking this as an input, the color of the ball as an input from the user. I make this change. I say that, okay, this is fine. This is working fine. Now it is time for me to make a backup of this or a checkpoint of this. So let's commit this. And for that, I made this commit. And as you can see, like we have another ID now, which is this 46 on the right. You can see this on the third blob. It says that 46 something something ID. It has a parent ID, that the parent ID is now the second node in the tree and not the first node. So it's just going one step upward, right? So we have this last node that points to the upper node in the parent ID, and then it has the changes that it had. So I deleted line 6 and I added line 6. That means I just modified line 6 from its earlier whatever it was. So it was like ball2 is equals to blue. Now I am just taking it as an input from the user, and then the message. So again, this tree can go on like forever, and this is how we make changes in our git. So this is mainly what you will be using every time you won't be collaborating with someone. This functionality, whatever we discussed up till this point, is enough for doing work on your own, and it is like something that you won't need a collaborator for. But this up till this point, we can get our git repository set up, we can add files, and we can track those files. So we have the 3 main functionalities of git so far, and this is all again working under the hood. We have not discussed like what is our implementation, and we'll be doing the hands-on after that. So but before that, whenever we are like working on separate features of code that is finalized, or let's say we are working with collaborators, we work on something called branches. And these are like the git branches that we talked about, which are like parallel pipelines. You can think about them as parallel pipelines. So git allows us to like work on these several parallel pipelines, and we how this is accomplished is basically git has one thing that is called the commits, which are these objects. Git also has another thing that is the head pointer or the branch pointer. So what this pointer does is it points to the branch as well as the head. So let's clear this out. So if you look on the right, we have our commit tree that is the same as what we had earlier, right? And we have these branches. We have currently only one branch, which is main, or you can call it master, but it's advisable to call it main. And this main branch has this ID in front of it. So this is 46A01E4, which signifies the last commit in this branch. All right, so this is just a pointer that points to the last commit in a branch. So whenever we are talking about branches are just pointers which corresponds to the pointers that points to the last commit in our branch. So for one branch, we have this last commit, and this pointer over here is the branch. All right. And we have this head, which is another pointer. So head is separate from the branch pointer in the way that head always point to the current commit. So if we are making several branches of our Git tree, it will still commit to the last commit that we have made in our whole tree. And this will get clear in the next slide. So if we see over here, let us like create a new branch, and let's say that I have completed my code that is for example plot. Now I want to add another functionality which does plotting or some another arbitrary function, anything. And that is to be done in another Python file. So let's say that I make a new file, and that is something xyz.py file, and I want to keep it separate from what I am doing on the main branch so that it does not disturb what is being done on the main branch for now. So what I'll do is I'll create a new branch for my code. So if you see the screenshot over here, the terminal screenshot, you can see I have made a new branch, and the syntax for that is git branch and then a branch name. This can be anything, but make sure you do not include any spaces. Just like a variable name, you can always create just similar to a variable name. So I have created a branch that is called example plot, since I am thinking of making this branch for plotting functions. All right. And whenever now I check like on which branch I am using the git status command, it still says that I'm on branch master. So this git branch command, what it does is it creates a new branch, but it does not land me into that new branch. And on the right, you can see now we have two different branches or two different pointers. But we made this branch, and we have not added anything or done anything to that branch. So you can see over here, like the main pointer and the example plot pointer, both of these point to the same node, that is the last node. And the head pointer is still on the main branch, since we have not shifted to the created branch. We have just made that branch. So the head is still on the main branch, and it is on the commit, that is the last commit. All right. So now we have made this branch, we now have to shift to this branch. So for that, like to shift to this new branch, we use this command called git checkout branch name. And if you see in this screenshot of my terminal, I did git checkout example plot, which was my branch name, and it says that I switched to branch example plot. And if I do a git status now to check where I am currently, it says that I am on branch example plot. That means I have shifted to this new branch. And if you can see like on the right, the commit tree is still the same. But if you see on the branches, we have two branches again, main and example plot, both of which are pointing to the last commit. The only difference now is that we have a head that points to the example plot branch. So this is to say that we are currently on the example plot branch, and the commit is still the last commit. So you can see like the head points to the current commit and the current branch. All right. Um, yeah. So there is, yeah. So on the left, the last point, if you see, so there is a note that I have added, that is to say like, if you look closely, the commits do not know anything about the branches that they are a part of. They only have these IDs and parent IDs and so on. They do not know like which branch are they a part of. And conversely, the branches are only pointers. It does not hold any they do not hold any information themselves. They are just pointing to the latest commit in that branch. That's all. So now let's do the functionality that we intended to do. So for branches, we created a branch so that we can have a new functionality. Then we shifted onto that branch. Now we want to develop the functionality in that branch that is to be separated or isolated from the main branch. All right. So we create a new Python file, any arbitrary Python file. I just used a Python file with one line, that is to say print something something. And just a second. Yeah. So over here you can see like our commit tree on the right. You can see if I made a file and committed that file, this created a new commit that is over here, like the 67205C71, the last node in, you can see. And the main branch is still pointing to this 46A or the second last commit, while the example plot branch is is pointing to this, the new commit, that is the 671. And on here over the branches or the box in this like right side, you can see the branches are now separate. So the main branch points to this 46 commit, while the example plot branch points to this 67 commit. And the head over here is like the current node. So that is to say that we are on example plot branch, and we have made this 67205 and so on commit. And on the left you can see the same like terminal screenshot in which I have implemented this. So if you see git status, we are on the example plot branch. I made a new code that I called as branch code.py. It's nothing but any arbitrary set of code that I wanted to keep separate from my main code, from the main branch. And what I did was I just added this. So git add branch code.py that staged these changes. Then I committed this change and said that added branch code.py in example plot branch so that I can understand what I did. And if I check the git status now, it says that I'm on branch example plot and I have already committed all the changes. So now things get a bit more complicated, and bear with me. So let me know if this is like too complicated and if you want me to go again on this. So now what I want to do is I am like a messy coder. So let's say that after I made this branch, I had a request from my collaborator or from someone who is using my code, and they said that I want all three balls to be taken as input from. So I want to make a change in a code that is present in the main branch now and not the other branch. So what I'll do is I'll check out to the main branch. So I'll go back to the main branch. I'll make my change in the code. I'll say that ball one is equals to input something, ball two is equals to input something, or so on, any arbitrary change that I want to make in the code. Then I'll add that for the staging. I'll add that code for the staging, and then I'll commit that. But now when I commit it, it should be on the main branch, since the user that is using my code is not aware of this example plot branch. Since this is still in development, the user is still working on the main branch, right? So he wants this change, or they want this change to be on the main branch. And whenever I make this commit, as you can see on the right, the new commit is now on the main branch and not on this example plot branch. So if you can see on the top, like top right, the box, the branches are now, the main branch is pointing to the new commit that is some B327 and so on. The example plot branch is still pointing to this same commit that we had earlier. And now you can clearly see the branch in the terminal, right? So these are two parallel functionalities that we are developing. So this is pointing to 6-7 something. And the head means like the current commit that we have made. So currently we are on the main branch and the last commit was B327. So that means our head points to the main branch and this last commit. And you can also see in the terminal on the left, we did the same thing. So we git checkout master, and it switched to master. We then on this branch, we check the status, and it said that we have a file that we have to stage for changes. We git added that. So git add python example.py, since we made the change in the same python file. And then we committed it with a message that is readable for us. So it says that to insertions, to deletions, and so on. And we have this structure in our git on the right. So after this, like after we have made all these things and we say that this example plot branch, the other branch we were working on, is finally done. We say that we have committed all the things on this branch in the same commit, in one commit that was 6-7 something something. And we say that now I'm confident that everything that is working in this branch is perfect. So I want that the user can also, the user who was using the main branch codes can also use this example plot. So for that, what I need to do is take this commit and take these files from this separate branch and merge this into the main branch. So this is called a git merge, and this is where we merge two branches so that we get the functionality that we want in one single branch. All right, so what we are doing is we have a main branch, we have this second branch that is example plot. We want to merge this 6 7 something something commit into this into the main branch. So we make a new commit, and this commit is like, this is made by this git merge command itself. There is like nothing new in this whole commit. It's just merging these two branches. So on the left you can see the on the left you can see the screenshot. So I'm just checking git status. I'm currently on branch master, so I have to be on the branch that I want the other branch to merge into. All right, so I want to be on the parent branch, or the branch that is to be added with. All right, so I am on branch master and I want to merge the second branch, that is example plot. So I write git merge example plot. And that means to say, like, I have this example plot branch that is to be merged into the latest commit that we have. So on the right you can see, like on the top right there's this box, branches box. So main branch is pointing to this 100644, which is the latest commit that came after merging these two. The example plot would have this last would still point to this last commit of the branch, that is 6 7 something. And we have our head pointer at the main branch and the latest commit. So the head always points to the latest commit irrespective of anything else. And this is how we combined two different codes. There were two different Python files, example python.py and branch python.py, I guess. And we have both of these in our main branch. So the user who was using this main branch can now use both these functionalities, and he did not have to check for us if we completed our development or if the code is still buggy. We merged this branch when we are sure that we had or made all the changes, and now it's time to merge this branch into the main branch and say that the user can now use this code. All right, so this is one major use of it. It can also be used for different users. So let's say that this example plot branch was used by another user who was working on some separate code. And when he was done with his code, when they were done with their code, they just merged this branch with the main branch. All right. And there can, so whenever we are doing this merging thing, there can be conflicts. That is to say, like, if there were two users who were working on the same file by any chance on these different branches, it is possible to work on the same file. But what and git also allows us to work on different, like, if I and the other person is working on different line numbers, it's still fine. It will all automatically like combine both these two code blocks. But in case like I and the other person was working on the same line, so let's say like line 15 was something that I wrote differently and the other person wrote differently, that would create a conflict. And that is to say that we need to merge this conflict and we have to resolve this conflict. So git cannot do this because it's something that we humans are developing and we know like what is the best for our code. So to merge this conflict, we have the conflict resolution, and you can see over here. So let's say that this line 15 had this print one statement in my code and print two statement in the other branch's code. So git does this thing and creates this like syntax. It says that the head pointer had this particular line of code at line number 15. So this first line is line number 15 where the conflict arises. And the second branch, or the example plot branch, had this print 2. So now it asks the user to like change this to whatever they want to change it to. So this is how we resolve the conflicts. So with this, we have like covered everything that is to be covered in the mechanics of the Git. And now you can like try installing this Git. So I'll just copy paste this link if I can, and then we'll try this on our own. So just a second, I'll copy paste this link. I guess I'll have to exit this. Yeah, so I have copied the link on the chat. So if you have a Mac, there is no need to do anything else. If you have a Linux, you can just check this website out. It has instructions. So you can just use this command and that would install Git. If you have Windows, there is a separate installable that is to be downloaded. So you can download it based on like whatever Windows system you have. And with this, like after you download this, you can get a terminal that is git scm. So I'll just work on that and like tell you how to do whatever we did currently. And just a second, I have a terminal open, right? So I am
That's good.
already made. Yeah, yeah.
Can we take a few questions while people install? Once they start installing, then there are a few questions, right?
Yeah, sure, man. You can take it. I can take it in the meanwhile, like if there are any other questions. It's not really-
There's Rohit, right? But there was that git init py file question. And
Yeah,
then do I need to always clone a repository?
yeah. So for the workflow that we are talking about right now, do not need to clone a repository. You are just making a new repository. So that is git init, and we can just link this with the GitHub repository that we make, and we'll be talking about that too. So we'll just connect this repository to the online repository, which is blank, and upload or push this repository to there. So you do not need to git clone it. But in case we already have a Git repository or a code set that is already present on GitHub that we want on our local system, then we use a Git clone. So I'll be talking about that when we talk about GitHub
Yeah.
and
Adrita
I
asks, since you mentioned here that there'll be, okay, sorry. So she wants, there'll be a hands-on exercise on creating new Git file. Can there also be a section where you could guide us to use a pre-existing Git?
yes, I'll do that.
And you again, this Adrita continues. Usually, when we use the pre-existing codes from the GitHub projects, the codes don't run, or maybe software versions do not match with the existing codes. How to solve this issue? That's it.
All right. Yeah, so I'll also talk about that. Yeah. So first of all, let's like if you have already installed, it's like pretty fast on Linux, but it does take some time. So if you have not installed Git on your systems, I'll advise you to like maybe look back at the video so that we do not run out of time. But I'll just like show you the tutorial ones. So here I have already created a new folder. So let's create just a fresh folder. So let's say that this is a folder named tutorial. I hope you can like see my terminal as well as my like file system, right? Um,
Yeah,
all right.
we can see.
Please stop. All right. So I have made a new
Can you
folder
zoom
that is
your
called
terminal a
tutorial.
little bit? The font is very small. Can you
All
zoom
right.
your? Yeah,
So is this fine? No?
yeah. This is good. This is good. I think it's fine.
All right.
Complete.
So currently we are on this parent folder that is astro sprint git, and now we want to like move on to our new folder that we created. So I'll just do a git cd tutorial so that we move on to this new folder that we created, and you can see like we are on this new folder. So first step was git init. So I'll just there was so if you can like just a second, I shared this link about the with the slides. So there is this summary that I have also written over there, so you can also refer to that while I'm doing this. And this also like lists all the things that we have already did. So we'll first git init, that is to say that we'll make this folder as a repository. So a git in after doing git init, it says that we have initialized a git repository in this particular folder. folder, and you can see like there is this .git file, that folder that it should have made, but you cannot see it here because it's a hidden folder. So what we can do is just cd into this folder. So cd.git, and I am in this git.git folder. And if you see like ls is to list all the subfolders in this folder. So you can see like there are a bunch of things over here. So we have objects, we have head, description, info, and so on. And right now these are all empty because this is an empty folder right now. So I'll just move back, and what I'll do is I'll copy paste any arbitrary set of code. So let's do this. Take this Python example code, and to see what this code is, so I'll just show you the code to Python example.py. So this is just saying that print welcome to Astro Sprint. This is for Git and GitHub tutorial and so on. So this is just an arbitrary set of code that I'm just checking. And now I have added this file in this folder, in our Git folder that we have initialized. I can check the status. So that is to say Git status. And you can see like we are on the branch master. We have not changed the name yet. There are no commits. So this is just since we initialized this repository. And then there is this untracked file that is python example.py. So what it says is we have to add this file to stage it. All right. So we do git add python example.py, and there is no output for this command. So we can check what happened with git status. And you can see like this is now green. It says that these changes are now to be committed. That means that this file is now added in or staged for changes. So this is now tracked. If I added this by mistake, I can do this git rm cached file to unstage it. But this was not a mistake, so I'll just commit it. So git commit. I'll add a message using -m, and the message would be like initial commit. And I also add like added python example.py. Right. So it says that we are on master branch. We have committed this, and there is this ID on the root commit. So you can see like this is an random any alphanumeric ID, and this is the message that I put in. It says that one file has changed. There were 10 lines in this file, so it says 10 insertions, and then it created a mode for this file.
Yeah. Can we pause, Chetan, for a minute?
Yeah, sure.
Is everybody moving fast, or does anyone have a problem? Participants, you can unmute yourself if you have an issue. Please tell us if any. I hope everybody is moving with Chetan. Please unmute yourself and ask in case you have a problem. What was your error, Anna? Yeah. Please, is everybody fine? Should he continue?
Yes, ma'am. It's fine with me.
All fine? All good? Okay. You're all moving with him, right? Yeah. I don't want people left behind. Yeah. Okay.
Yes, ma'am.
Yeah. So go on, Chetan. Go on.
Sure.
Thanks.
Please feel free to like interrupt me in between if I go too fast.
I've anyway done it many times.
No issue at all. So right now we have made the first commit. So if you remember our slides, we have made that first blob of our code objects in our Git model. So let's say that I want to change something in this file. So let's open it with any text editor. I'll use Sublime Text for now. And I'll just say that this is first change. And that's all. I'm just making any arbitrary set of change and just saving this file. So once this file is saved, I can go back to my terminal and see like what is the status now. So it says that changes are not staged for this commit. That means like we have changed or modified this file, but the changes are not like staged. So what we have to do for staging, we have to git add this file. So we add this file, and once we add this file, these changes should be staged or added. So if I do a git status, it says that we have modified this file and these changes are now to be committed. So these are tracked now. So let's do a commit. That is to say git commit m, and then like say we added first change. So in and file name also, so that it's like easier for us to understand at a later stage as well. So you can see we have made the second commit. Now this commit would be pointing to its parent ID. And that is again all under the hood. All you have to do is to just use these set of commands and it will do everything that we talked about under the hood. And you can see like we have already made a git tree. Now if we, so we have already covered the three main commands that we wanted to do: git init, git add, and git commit. If we want to make branches, so this is something that you won't be using too much, but I'll still go over this. So let's make another branch and say that get branch, get branch, and then any name. So branch one. So it created a grid branch, but if I do git status, I'm still on branch master. I have to move to this branch to make any changes. So I'll just git checkout to move to the second branch. So this is branch one, git checkout branch one. And it says that I have now switched to branch one. So everything I commit from now on will go into the branch one. And the main would be untouched. All right. So even if I make changes in this folder, so let's go ahead and copy this. Sorry, did someone had any question? I guess no. So I'll just copy paste this code, another code that is another arbitrary code.
ठीक ठाक सब ठीक ठाक ହେଇଗଲା एग्जाम भी ठीक ठाक ହେଇଗଲା
I guess someone is on mute.
Yeah, I think someone got. I'll do it. Don't worry.
Yeah, thanks. So if you see this code, it's just like another arbitrary set of code which says that this is a code for the new branch. That's all. That's the code. And what we want to do is we want to commit this change. So if you do git status now, it says that we have untracked files and we are on branch one. So we want to add this file to our branch. So let's say that git add branch code. Oh, sorry, .py. Just sorry for that. Just a second. So we have added this branch code.py, and now if I do again a git status, so git status is a very helpful command to see like where we are and what is the status of the git repository, and like make sure to use it regularly. So we are on branch one. We have added this file for committing. So let's go ahead and commit. Git commit /m added new change in branch one. So you can see one file is changed. There is one insertion since that was only one line of code. And if I do git status now, it says that I'm on branch one, and there is nothing to commit. So if we look back, we can see like there are still two files in the same folder. However, they are in Git, they are present in different branches. So if someone was to if someone was to use your main branch, he or she or they would only access this first code and not the second code, so that it does not it is basically isolated from one another. And whenever we want to like merge these branches, we can just go ahead and say git merge. So for that, we'll just move on to our main branch, and that is called master. So we'll do git checkout master. Since we need to be in the branch that we want the other branch to add on to, right? So we added this new branch, and if I do git status now, it says that I'm on branch master. I want to now merge this other branch. So I'll git merge branch one. Not something we can merge. All right. What's the error? Did we miss? Okay, I made this mistake of like this is a typo. I missed the n. So once I did this git merge, it updated this and it is writing some things. But now on the main branch, we have two files. So if I do git status, I'm still on branch master. And if I make any change in this new this other file, it will also be reflected on the main branch. So I have if the user wants to like download the main branch, they will have both of these codes now. All right. So these were all the commands that we discussed so far. So any doubts, you can like write it in the Chat. All right. I see a question in the chat. What is the difference between Git and Unix? And know about the modification. So Unix is basically like an operating system that is like so the basic difference between Unix and Git is just a source control system. All right. So it is used for the making these repositories, adding in files, tracking changes. Whereas Unix otherwise is an operating system and a language too. So you can make shell scripts on Unix that can run, and you can make executable file systems and executable things. Also, you can have a file structure. So that is basically the main difference. So these are two very separate things. Git is just used for source control. Unix is a whole operating system. So you can write code in Unix as well. So there can be shell scripts and so on. Any other question? We can ask any other question, or if not, we can move ahead. I hope like you were able to follow this. And Dr. Priya, we are overshooting a bit. Is it fine if I continue the?
It's okay. It's okay. Yours is the only session today.
All
So
right.
that's, I've kept it light on weekdays, so there's only one talk on weekdays.
Yeah.
So otherwise people will get tired. But you can, whatever, plan and wrap up.
All right. So let's move forward with our presentation. And so can you see my presentation in presentation mode?
Yes, it's fine.
So we have this summary that we did. We created a repository using Git init. We added file names using Git add. We checked the status using Git status. We did the commit using Git commit. And we did branching using Git branch. And using the created branch, we did Git checkout to move to that branch. And for merging that branch, we just we did checkout on the master branch and merged the branch. All right. So this was all about Git. And now let's talk about GitHub. And most of your questions would be solved using this. So GitHub is an online hosting website for hosting your repositories that you make either publicly or privately. And it also adds in several functions and not functions, you can say like several functionalities that make open source development easier, like creating documents on their own. And there are all sets of new functionalities that are being added in GitHub every day. So we'll talk about some of them. And GitHub also enables us to collaborate with people around the world. So in Git, you have to have a distributed system, or you so that you can give your folder to someone else. But in GitHub, it is now hosted online, so anyone can clone your repository and work on it and put it back. So using GitHub is GitHub is just if sometimes we get confused between Git and GitHub. So Git is the control system, version control and source control system, while GitHub is just an online repository or online forum for using these Gits on a server or on a shared space. So for Git, you can go right now to github.com and make your account. And we'll also try this out right now. And we can make a new repository. If you are working on a new repository, totally new repository, we can make an empty repository. But if there was a repository already present by someone else, say, so we use git clone. So as I talked earlier about this, if I had this astrosprint git repository, I'll just copy paste this whole URL that I get from the repository itself, and I'll show you where we can get it. And I can do this git clone. So what this does is it takes the whole repository that is present online and it makes a copy of it on my local machine. On my local machine, I can change the codes however I want, and then I can upload it to the online repository using a set of commands. So that we'll also discuss. But so your question also relates to this. So for repositories that are our own, we can use this very easily, since we are cloning our repository and we are also making changes and uploading the same to our own repository. But if we are working on someone else's repository that we cannot make the changes onto directly, All right, so we can clone that repository still. We can make those changes. However, we should do this on our local system. So basically, all right, I'll leave it at that. I'll just talk about it, and there is a slide that discusses this specifically. So using GitHub for our case, what we'll do is the folder that we just made, all right, the master and branch one folder that we just made, we'll add that to a GitHub repository. And what we'll do is we'll like check that if that is fine, and we'll also create this whole thing on GitHub instead of Git. So let me just exit this. Yeah. So I have like logged into this GitHub. If you have not, you can make your own profile, and it's like really simple. You just have to put in your email address and so on. If you open a github.com, so you can just sign up over here. You'll have to put in your enter your email, and I guess this is a new functionality again that they have made. This is like a new interface. So you'll just have to put in your email and so on, and you'll be good to go. And once you are here, you will find something like this should be empty, but since like I am following some people, this is filled with other repositories and their updates. On the left you will see your repositories. This will also be empty since you do not have any repositories yet. These logged ones are the ones like I have private repositories, while these other ones, the book ones, are the ones that are available to open public. So anyone can clone this and work on this, while these are hidden from everyone. So what we are going to do is we are going to create a new repository. All right, so we'll make this new repository, let's say Git tutorial. I hope this name is not taken. Yeah. So the name, you can have like unique, you should have unique repository names under your owner name. So I have put in Git tutorial. So I can put in a description, but right now I'm not doing that. I'm just making this private so that like this is just for us to see. And then I am not adding these three, but in case you are like doing this freshly, you do not have anything on your local computer, you can also add a readme file and a git ignore file. So once you like add a git ignore file, you can select the language. So we are using, if we say like we are using Python, I can add a Python git ignore file, and it will automatically add a set of files that we have to ignore generally when we are using Python. Python also creates some PyC extensions and so on. So right now, since I want my local repository to go into the online repository, and I'm not using git clone, I am just making a empty repository. All right, so I have done nothing. I have not put in a description, readme, anything else. I have just made it private and given it a name, and then I'm creating this repository. You can also follow along with me if you want. So if you see over here, we have made this repository, and there are some things over here like code, issues, pull requests, actions, and so on. What we are concerned with right now is our code, which is the folder or the repository that we are talking about. And you can see like there are some set of commands that it says you can use. So to push an existing repository from the command line, which is what we want to do, since we have already done this, we have created a new repository on the command line. We want to push an existing repository from the command line. So for that, we'll add this remote, and this is the URL of the repository that we just made. So this is hosted on github.com/Chetan Chawla, which is my username, and then git tutorial.git. So I'll just copy this and just add this on my terminal. So let's go back to this. Yeah. So we are on the same folder. All right. So I want to add this remote location, and this was a command I just copy pasted from the GitHub. And it says git remote add origin. So what it is basically saying is remote means like we are linking it to a remote server. Add means like we are adding an origin, that is like whenever I want to push or pull, I mean download or upload something on from the repository and to the repository, I'll just do this on this URL. So I added this as a remote, and this won't give any output since it is something that is to be done in the configuration. So it automatically changes the configuration of this repository and not other repositories. So it added this for the particular repository. Then the second thing is git branch m main. So this is just to say like, so as I talked about earlier, the master terminology is being reduced, since it's like, it is not a very good term. Master slave is not a good term to use in technology, and we should be inclusionary. So GitHub has totally moved to this main terminology instead of master terminology. So it says that you should already change your master terminology, and that is to say git branch m main. So this command just changes my master's terminology to main terminology. All right. So this is to say my master branch is now my main branch. And then it says push origin main. So git push means like I am pushing it to the online server. So that is to upload my whole repository to online. So if I do git push hyphen u origin main, so you can like remove this part after the first time. This is just for the first time, and to say like I want to add only the main branch on the like on the online repository. So I'll just enter this, and it's doing something. It is counting objects and doing some compression and so on. And after that, it has like added this main branch to this repository online. So I can go over here and refresh this page to see if my whole repository is over here or not. So you can see on the top left here, we have the branches. So I've only pushed the main branch. That is why I only have main branch over here, which is the default branch. Then I have these two codes that I added over here. So these are the same codes that we created. So this is how we add in a repository that we made on our local system to GitHub. All right. And if I wanted to use another repository that was already built, so let me take an example of one of my own. So this is a repository that I made with some collaborators, and this is the README file that we were talking about. So the README file has some set of, this is a markdown file, which is something similar to something just a bit similar to HTML, but a bit different as well. But this is a markdown language. So that is to say like we can add headings and images and so on, and we can add some text in a formatted manner. So I have added in a README file, and you can see a bunch of other files over here. I want to download this whole repository onto my local. And one more thing before this, so we can also see the git ignore file. So this is pre-generated git ignore file. If I specify that the Python is my version, like Python is my language that I'm going to use. So it adds in some set of file names, and this hashtag ones are just comments. The other ones are file names. So it will ignore all these files whenever I'm doing git add star. All right. So if I wanted to have this on my local system, I'll just go on the screen button and say, and just copy paste this. So this, I'll just move on to another folder. Let's say I'll just move one folder back and see like which folder I'm in. So I'm in the parent folder of the folder that we were working on. So I'm in Astro Sprint Git, and I want to clone this repository. So I'll just type in git clone and then copy paste the URL that I found from there. And if I enter this, it will be cloning into this whole folder. So, all right, this is done. So if you can see in this Astro Sprint Git folder, I have this Gaia curves repository that I downloaded. So your question from earlier, if there were some codes that were not running on your system because of some version issues in the software. So for that, there is this file called requirements.txt. Okay, you can open this requirements.txt file. Right now, it has only 5 requirements. This can also come with a version number. So this is something that is to be done on the developer end. So if you are using someone else's library, you'll have to check if they have included this or not. So you cannot do this on your own, but this is something you'll have to check. So you can have a version specified. So that can say like Astro query greater than equal to 1.0. That means like the version in your system must be greater than 1.0 of this Astro query. And whenever like this is again was how they set up their profile. So if I were to do this, like install this on my system, I have I have like put in some installation instructions as well. So I can install it using pip if you are familiar with Python. So pip install -e dot would install all these things. And while installing this, it will go into this requirements.txt file. And if these softwares are not present on your system or the versions are separate, it will automatically download these softwares on your system. So that is how you can remove the discrepancies with other people's, with your own repositories. For other people's repositories, you'll have to they'll have to put in this version number somewhere, or else you won't be able to get why your code is failing. Sometimes you'll have to debug it. And one more thing about the same thing is, your question is again, you can also try in using fresh virtual environments. So I guess Anaconda was discussed yesterday. I saw face talk on YouTube. So Anaconda was discussed. So Conda allows us to create separate virtual environments which are isolated from one another. So you can install only the required softwares in that. So that is one way to ensure that there are no dependency issues. Moving on to the last part, I'll just go through it quickly. So we did this whole thing. We remote added, and we put in the git branch. I'm so sorry. Yeah, I hope this is visible now. So on the third line, we have said that get push u origin main. So this is to be done whenever we are uploading something. And this is also to be done whenever we are making new changes. So let's say that I want to make a new change. I'll still commit this and then I'll push this to the main. So I'll also see this. So this is another meme that you can appreciate. So it's advisable to do git commit and git push your last code iterations whenever you are shutting your system or doing something considerably different. And if there are multiple machines that we want to set this repository onto, we can clone this repository onto other machines. These are just some useful FYIs. And to download any changes that are present in the online system. So let's say I have two different laptops. On one, I develop code and I commit that code. I push that change onto the online repository. So that means on my first local laptop, I have the changes. I have pushed that onto the server, that is GitHub. Now I want my other machine to know that what the changes I made, and it should have all those changes. So from this laptop, from first laptop, I did a git push to the server. And on the second laptop, I did a git pull. That is to say that I downloaded all the changes. So this is git pull for any changes that are present in the GitHub repository. And for working with collaborators, so this is I won't be going into details at all because this is really complex if you start working on it from the scratch. But I have included a link and some photos, a small introduction as well. So it will be easy if you go through that, and it will take around 15 to 20 minutes more. But this is something that you need to go on your own. But to give you an introduction about that, so in case we need to work with several users, we first need to make a great clone. So let's say that I used Dr. Priya's AstroSprint. Let's say that there is an arbitrary repository AstroSprint on GitHub. I first have to fork it onto my own system. So I'll just show you what this fork button does. And I think we have not discussed this. Yeah. After we fork this, just remember, we have to do something that is called fork, and I'll just talk about this. And then after we fork this, we have to clone this into our local system. After we clone this, we make our changes into this system. After we make these changes, we push this onto the repository that is Chetan Chawla /AstroSprint. That is our local repository on GitHub. And after we have made all my changes, I want Dr. Priya to take this repository and include it into the main repository. That is her repository. All right. So I will make a pull request using GitHub. which is to say I explain all the changes that I made and I want Dr. Priya to include it into the main repository from my local copy of this repository. So I make a pull request. Then Dr. Priya can see and like check what all changes I made, and if those are fine or not, then she can accept or decline that request. If she accepts those requests, all the changes would automatically be reflected in the main repository. And these are just another word of caution. So whenever we are, you can like read this out, but it's just to say, like, whenever we are doing any changes, we should check if there are no more changes in the main repository, and if there are, we can pull those changes into our own version of the repository. All right, and then this is just the last thing. We have already tried it. So forking is basically, let's say that I'll again go on to this repository. So this is one repository that I want to make a change onto. So first of all, I'll fork this repository. All right, so okay, it says that I've already did. I'll just choose another line. Just a second. So let's say that this is a repository that I want to make some changes onto. This is an exoplanet repository. So what I'll do is I can fork this repository into my own repository, into my own user. So if I do this, it will make a copy of this whole repository over my local user. So that is to say, on GitHub, this is forked from this main repository, that is hipk/voten, and this is my version of this repository. All right, so if I want to make any changes, I should make this on this particular repository, that is local version of this repository, since like I do not have access to this main repository. All right, so what I'll do is I'll git clone it on my local system and I'll make the changes. After making the changes, I'll push the changes onto this local repository. And once I have done this, I'll go on to pull request and put in a new pull request. All right, I'll not do this since this will create a new request that will notify HipK. But otherwise, I'll put a new pull request. And you do not have to do anything over here. You just have to write a message like what all changes you have made and what all you want HipK to know. And that's it. HipK would check what all changes you made. And if they are fine with it, they'll say that, okay, I accept this request, and that would be merged onto the main one. And the last part, that is this Git flow, is one way of working with collaborators. It is the standard way of doing things. So we have this hierarchy of things. These are branches that you see. So we have this main branch that is to be used by the users, the end users. So this is almost clean. This is almost always very clean. So we do not do any development on this. We only push things over here. So we say that this is version 0.1. We make a commit. Then we create a new branch, that is the develop branch. On this develop branch, we make separate branches for each feature that we want. So let's say I want to make a feature for plotting and I want to make a feature for giving the ball colors. So I made two branches, one here and one over here. And whenever I complete this functionality, I just merge this onto the develop branch, and this develop branch would go on parallelly. But we can like after we are at a stage that we say that, okay, I have developed enough to make a new version of the main code for the users, I put this develop branch into the main branch. All right, so this is just a standard way of doing things. So having three different types of branches. One is the main branch, which is for the users. One is the develop branch, which is for development, and the separate feature branches for each of the features, so that nothing gets mixed up. And that is all. I think we tried it on our own. Like right now, you can also go back to this video and try this on your own. And this is just a summary. I hope that this is your reaction now. Like I hated Git, now I hate it less. I just put it onto slide mode so that it's easier to read. And then in case of fire or in case of anything, as I said earlier, you just go on and do git commit, git push, and then get out. Okay. And these are all memes that I stole from somewhere. I have referenced that on the end. If you want to, like, you can check that blog out. And for the summary, we clone a repository if it is already made. We add file names, we commit the changes, we get push those changes. And whenever we are working on another laptop, or if there are any other changes that we made, we get pull it before that. And that's all. Thank you for listening. If you have any questions, you can mail me, or you can send a message on my Twitter. And these are some more references. So you can check these out. There is this Git cheat sheet that lists out all the commands. The first one is an intro to Git mechanics and Git flow. This is the Jason Wang's slides that I talked about earlier. And then there's this blog post that had all these memes. And there's this official Git book, which is like too detailed for you to understand. I think this is all that you would need, but you can still refer to it. And like most other programming things, you can always Google. So, all right. Yeah. Thank you.
Thanks, Chetan. That was really very nice. But you won't be too happy to see the last question, which I see over here by Adrita Khan. After the whole story, Adrita, that's not fair. She says, is there any alternate to Git? Isn't it easier to just manually add folders to GitHub instead of using push-pull commands?
Yeah, so this is possible, right? But there are some things that you won't be able to do. So if you want to do it, it is definitely possible, but Git is working on your local computer. So you can make 1,000 sets of commits and then push it just once. It will still push all those 1,000 commits at once. So you do not need to have internet access for all those 1,000 commits. You just need internet access for one time. All right, second
I don't
thing.
think the issue is internet access, right? I think the issue, Adrita, if you want to talk, I think her issue is not internet access. I think it's just the keeping track of what has been, you shouldn't end up pushing and pulling the wrong things, right? You can
Right.
override.
So for that, like what I do is I use this simple flow of just doing git status. It tells me all the files that are to be tracked or to be added or to be committed. And then I see like what files I do want to push. And if there are some files or folders that I never want to push, like some data folders that I never want to push, I just put that in the .git ignore file so that they never come up again and again. So I can like eliminate those and just track only the files that I need to like keep a track of every time I do git status. And then you definitely do not need to do git push and pull every time. You just need to git add and git commit. And this is something like personally I do this on a regular basis, on the basis like if I do something like 250 300 lines of code and I think that okay, this is a fine enough checkpoint, I only then do git commit and not like after every 10 lines 20 lines. So you can like reduce the frequency if you want, but I think like going on to GitHub and uploading it would still take more time.
Yeah. And by the way, you were supposed to tell us your story in brief.
All right. Yeah, I'll do. I'll just drink some water first.
Yeah, but the others, please pass on your questions. Yeah, even I think the Git thing is a little complicated to understand. I myself just getting used to it. I'm not yet so comfortable with it. So are there any more questions or? But for most of y'all, especially the ones of y'all who will go in for PhD programs or this thing stuff, these are tools which, you'll have to be using. I think it's getting more and more essential. Yeah. Chetan, start. You can start and I'll let you know the questions after you finish.
Yeah, sure. So I'll briefly talk about myself and what I am doing, how I am doing it. So my story starts from a BTech. That is like the story of most of Indian students, I feel. And I did like electronics engineering, electronics and communication engineering in BTech, and I completed that in 2019. But I always had an interest in astronomy. Like since I was a kid, I used to like look at these books in the library and go crazy over them, like how pretty this looks. So just by that, that's all. I never thought I could really go into astronomy, or I never really thought about if astronomy is a professional field, if you can earn livable wages and so on using doing astronomy. So I never like thought about doing astronomy before that. But after I finished my just before I was finishing up my BTech, I had this thought that I should go into astronomy because I like really like what people are doing in that, and the discoveries that are going on. However, there was this financial strain thing that if I were to do a master's or something, I do need some financial stability in my life. So I joined as a data analyst in a consulting firm in Delhi and in Gurgaon, basically in India. And that over there, I worked on a completely different thing. But now I am doing astronomy. I do feel like a lot of those things are directly used over here. I used a lot of Python. I used a lot of Unix SQL, Unix shell scripts. I used a lot of SQL. Like there is a language called ADQL that is, I guess you know like a bit of Gaia. So Gaia has this tool ADQL, astronomical data query language, that is really really similar to SQL, and that is also something directly that can be used. And then there were and then yeah, so I also use some dashboarding tools and so on. So I think I got a lot of knowledge from that I can leverage onto astronomy. But in January 2021 I left the field, and in last year I also did some courses and so on, like online courses. And there was this one more course that Dr. Priya was also a mentor of this year. So this was called Intro to Astro, and it was a 10-week course. Faye was the co-organizer this time, and this like gave me a gate of opening, like how we can get into astronomy, how we can talk to people. So I got into it. I left my job and I started finding things. I started attending conferences, workshops, and so on. Since everything is online, I think like online conferences and workshops are still not close to what we can have in an offline format, but it's still something that is accessible to now is accessible to people like us who are living in India and could not afford to like go to every conference in different countries and so on. So it opened a gate of like having conferences and so on, meeting people. So I met a lot of people. I made a list of all the research internships that were available around the world. When after I left the internship and saw like in which of them I am eligible in, I filled some of those. I got an internship at Asia Taiwan. So that is, I am currently working on exoplanets itself. So I do like I work on test data to find exoplanets. So I work on transit detection methods of finding exoplanets, and I'm looking at the CVZ. So CVZ is the continuous viewing zone, if that was discussed yesterday in the test session. So continuous viewing zones are basically, if you know, like test looks at some sectors in the sky, and there are some overlaps in between these sectors, and on the poles of the like earth, or you can say the galactic poles, there is a continuous viewing zone for whole 365 days that test stays on the same horizon. So I look at those and I am trying to find planets over there. And I work with Dr. Alex Tichy, and he's a postdoc fellow at Asia Taiwan. He also works on exomoons and stuff like that. So yeah, and I'm continuing like my research internship after the summer one. So that was one way of getting into it. And what my main like crux of the whole thing was is that it is possible for everyone, even if you are from BTech or any other field, even if you are doing a job, even if you want to get into data science. I saw someone saying that they want to go into data science. I think it is fine to go into data science or data analysis before like going for astronomy. And I still cannot like vouch that I will get a PhD or something, since I will be applying this fall. But I definitely like I have talked to a lot of people, and I think that it is definitely possible. If not this year, maybe next year, but it is definitely possible for all of us to take any route that we want and still end up where we want to be. So it's never too like shabby to try different things and not just stick on one route. And that would be all. Yeah.
Thanks, Chetan, for those encouraging words. I think it does help to hear that. Um, there's still some more questions. So Adrita asked that since you mentioned that in Anaconda we can install the exact needed version, can you also give a reference to that? I recently got to know about Docker container, which automatically installs all required dependencies.
Yeah.
Yeah, now I'm going to let people unmute themselves. I had stopped it because there was a disturbance coming. So if you all want to unmute also, you all can unmute. Yeah, Adrita, whoever.
So based on that question, I can answer Conda does make virtual environments, and that is something like you can set up environment on your whole system, and this is really similar to Docker container. A Docker container is like a more useful tool in the sense that it is more packaged and needs less of us users to do, but it is sophisticated on the developer end. Whereas for Conda, it is not that sophisticated. So for Conda, what we can do is make a virtual environment, and I can share you the link as well, maybe on the Telegram chat. So you can just have an environment, a Conda environment that has a set of predefined libraries that are standard for everything. Other than that, you can install your own libraries. After you are done doing that, after you have all the libraries for your development, if you want to do it, if you want to install your package onto another laptop and do not want to mess with the dependencies and so on, like versions of the dependencies, you just have to export that version or the virtual environment as a YML file that just says like, please install these packages and these versions of these packages. And you can just this is a tool that Anaconda provides, so you can upload this on Anaconda server and then just install that virtual environment on the second computer or second laptop, whatever, and that would automatically install all the softwares and along with the versions. So this is similar to Docker, but it's like a bit more like you have to write 2 or 3 commands on the user end as well, but it is simpler on the developer end. Yeah, that would be all about this question. So I'm reading the questions, and so you can definitely reach out to me on my email, or I'll be on the Telegram group as well, so you can message me over there.
Mohammed Asif. Hi there. First of all, thank you for giving your precious time. I have a question. I've completed MSc from Garhwal Central University, Dehradun. There in second year, I wrote a review paper about F87 black hole, but due to COVID crisis, I was not able to learn languages like Python, Fortran programming. Can you suggest me how I can come out of the square?
So I think
I work on exoplanets. Okay.
Right.
But we had the TP saying we had the test session yesterday. Right?
Yeah. So exactly.
And before this, we've already had Kepler. Kepler has already been done. We did tests also. So that's covered. Yeah.
So yeah, Asif, like first of all, like about Python and Fortran. So I'm not too sure about how to run Fortran, but about Python, I can definitely guide you. So Python is like really too much available on the internet. So you can find several tutorials and so on. I'll share you some links that you can learn Python from. And there was this, as I talked about this course, that Intro to Astro course. It gave us like first 2 weeks were only dedicated to using Python, Unix, and all these programming languages and libraries that are used in astronomy, like matplotlib, numpy, and so on. So you can definitely check that out. But once you get through the basics of Python or any programming language, I would definitely recommend you to like go and try doing a project. And this is where I guess Astro Sprint would come handy, and there are projects that you can do. So once you do a project, you'll find several things that you cannot just do by learning things using a lecture or using some guide, right? So you'll get to work with some data, you'll get to know where things work, where things don't work, and how to find things. So a lot of programming languages are just like this. You will have to Google a lot of stuff, and you get to know what all things are there and what all like small things are there in the programming language and what you can use in astronomy. So since Python and these languages are like really diverse, I would not recommend you to go to very detail of these languages, since most of those things would not be useful for you. And for the other thing, I think, yeah, so if you want to work on exoplanets, as Dr. Priya said, like we had sessions yesterday, tests, and we had an earlier session on Kepler. You can definitely work with them, and again you can also check out this Intro to Astro course that I am talking about. I'll definitely share the link. This was an 8 weeks course, and all the videos are uploaded on YouTube along with all the content and all the code that we like developed on the GitHub.
I think there's plenty of stuff to work out projects using that too. Yeah.
Right, exactly.
Okay. Yeah. So, thank you, Chetan, for your time. I think sorry that happened. Okay, and Ankur has shared this. Ankur, share it on the Telegram, this thing, because this will be lost. You will share it on the Telegram. Okay.
Yes, ma'am, I'll do that.
Okay, fine. So I think we'll wind up today. Thanks a lot, Chetan. And we meet again tomorrow, 6 o'clock in the evening. Tomorrow we do LaTeX overleaf. And so that will be tomorrow. So see you all tomorrow at 6 o'clock. 1 minute. Huh? There's some 2 messages. Oh, there's just a thanks. Thanks a lot. Okay. Thanks a lot. Thanks, Chetan.
Yeah,
Bye.
thank you,
Bye.
ma'am. Bye-bye.